Hello everyone, so welcome to the YouTube channel of YourPedia here. I am Vinesh Sharma, your mechanical mentor. So as you know, the Andhra Pradesh has announced the vacancies for the Industrial Promotion Officer, okay, and the paper 1 and the paper 2 is there, okay, in which the paper 2 is related to the some technical part here, in which you have to cover up the physics, chemistry, mathematics along with the industrial engineering, and there is some other topics related to the industrial part here, okay. Now related to this particular post, I am going to discuss a very important topic that is related to the chemistry, okay, and in chemistry they have mentioned one topic as fuel, which we are going to see in the today's lecture here, okay. Now along with that, before proceeding further, I am going to give you one more information that the module of this particular post has already been announced, okay. The live classes are going on from the last week here, okay. So if you want to join us, you can join us as soon as possible here and start preparing here, okay. Now let us start our first topic. So just see, this topic is going to be a very simple topic for you in the chemistry part, and you can expect 3 to 4 questions related to this particular topic here. And what are the important points which we have to discuss in this particular chapter here? So here we have to talk about first that what is the meaning of fuels, how do we classify them, okay, and we have to compare the different types of fuel also, like we have a solid fuels, liquid fuels and gaseous fuel. So we are going to talk about each of these fuels here, okay. Now along with that, we are going to see the calculation related to the calorific value. So there are some experimental method to calculate the values here. Along with that, we are having some theoretical calculations also. So in the live classes, we are going to see the theoretical calculations here. Along with that, we are going to talk about the experimental methods related to the Bohm's calorimeter here, or I can say the Boy gas calorimeter or the Juncker calorimeter here, okay. Now so first of all, just see what is the meaning of fuels here and why it is important here. Because if you just see the applications of the fuels are going to be used in each and every sector here, okay. Now it has a wide applications here, and we generally use the fuels in our household also, okay. Now like we have a general usage of the LPG, or I can say PNG. Before that, we use a solid fuels like wood in the villages here. So we see a very wide applications here in our household also, as well as in the industrial. If you just see whether it is related to the power plant, whether it is related to the automobile engine, we find its application here, okay. Now so here the first thing, how do we define the fuels first, okay. Fuel are nothing but these are the hydrocarbons here, okay. We can say it is having a constituent of carbon as well as the hydrogens, okay, that produces a very large amount of heat whenever we burn this substance here, okay. Now so that is a required condition. So now the main constituents are the carbon and hydrogen. That is why the fuels are also known as the hydrocarbon fuels here, okay. And in the fuel we may also see the some amount of sulfur also. So there is not a necessary condition that we are going to see the presence of sulfur, but there may be a chance again, okay. Now and there is one important term related to the fuel which we have to understand, that is the calorific value. What is the meaning of calorific value here? See, whenever you burn some amount of fuel here, there is a generation of the heat here. So I can say the amount of heat generated by burning the 1 kg of fuel is known as the calorific value here, okay. Now so whenever you are calculating the value of the calorific value for the solid fuels or liquid fuels here, along with the gaseous fuel, the representation is in different form here. For example, whenever we classify the fuel here, there we have a classification in the form of solid fuels here, then we may have a liquid fuels, along with that we may have a gaseous fuel here. So whenever you are calculating the calorific values for the solid and the liquid, they are generally represented in the form of kilojoule per kg here. That means by burning the 1 kg of fuel, how much heat is going to be get liberated from the fuel, it is known as the calorific value here. But if we talk about the gases, in this case, in the case of gases, we don't consider the certain amount of the fuel here, okay. We don't have a fixed amount of mass of the gas here. Here we have a fixed volume. So I can say the calorific value is generally represented in the form of kilojoule per meter cube. Remember this condition, okay. Now so there is a proper way to calculate all of these things here. They are the theoretical calculations here. Along with that, we have some experimental formulation here to do the calculations here, okay. Now let us start with the first part. How do we classify the fuels and where do we see its applications here? Now coming back to its classification, first of all, just see the fuels can be classified into the 2 different ways. Either we may have a natural fuels here, or either we may have a prepared fuels, okay. Now these 2 type of fuels are further classified into the 3 types here, depending upon their chemical composition, okay. Now along with that, depending upon their phases also. So there we may have a solid fuels here. There may be a type of a liquid fuel. Also we may have a gaseous fuel here. So if we talk about a solid fuels, in the case of solid fuels, okay, just see what I have told you. In each of these category, we are going to have a natural fuels as well as we are going to have a prepared fuels here. So if we talk about the natural solid fuels here, we are having a wood, peat, coal, or I can say we may have a different types of anthracite, bituminous, okay, or the lignite here. These are the preparatory stages of the coal here. Now coming back to the liquid fuels, in the case of liquid fuels, we have a natural petroleum which is basically derived from the crude oil. Okay, so by doing the fractional distillation process, or either we can do the cracking process to obtain the different types of gases here. So for example, if you just see, whenever we perform the fractional distillation of the crude oil, we may have a formation of the petrol first. Then you are going to get the diesel here. Then you are going to get the heavy soluble oils here. Okay, so we can get the different types of the liquid fuels, okay, by doing the cracking process or by doing the fractional distillation of the crude oil. Now coming back to the gaseous fuel, in the gaseous fuel we are having a natural gases here, and also we are having the various manufactured gases like coal gas or the producer gas here. Okay, so in each of these category you are going to have some natural fuels here, and along with that you are going to have a prepared fuels. How we have obtained the prepared fuels here? By doing some I can say processing here, we are obtaining the prepared fuels here. Okay, now just see, in this particular video I am not going to go into so much detail here that I will cover the each and every part of the solid fuels, liquid fuels, or I can say the gaseous fuel here. I am going to cover just the solid fuels here. Okay, now how they are going to classify further, and we are going to see the liquid fuels and how the liquid fuels are different from the solid fuels. That what are the merits and demerits of the liquid fuels over the solid fuels, we are going to talk in this particular video here. Okay, now let us move toward the next part. So first of all, if we talk about the solid fuels here, the first we are going to have a natural solid fuel. So what are natural solid fuels here? Which are present in the earth crust. So there we may have a wood, peat, lignite, which is also known as the brown coal, bituminous coal, anthracite coal. All of these type of the fuels are considered as a naturally solid fuels which are present in the earth here. Okay, now we can prepare the I can say artificial fuel or the prepared fuels from the natural fuels only. So here you can see both the charcoal, coke, briquette and the pulverized coal are nothing but these are the prepared fuels from the natural fuels here only. Okay, for example, if we talk about the peat here, so let us start with the first solid fuel, that is peat. So it is the first stage in the formation of a coal here. Whenever you are forming the coal, we may have a different type of stages: first stage, second stage, third stage and fourth stage here. Okay, now so here if we talk about the first stage, here we have first stage as a peat. Now in this case, if you just see, in the formation of the peat, we may have a very huge amount of the water content. Huge amount of water content is being present. It is around 30% that you have to remember. And whenever you want to use the peat coal, you have to make ensure that it is properly dried before usage here. Okay, and if we talk about its calorific value, how much heat it is going to release after burning the 1 kg here. So it is having a value approximately equal to 23,000 kilojoule per kg there. Okay, just remember this condition. So these values are very important for you. Now coming back to the lignite or brown coal. So first just see, if you are doing the formation of a coal here, in that case the first stage we have seen, that is known as the peat here. Now the second stage which we are having is a lignite or the brown coal. Now in this case you are going to see it is having a nearly about 40% moisture as compared to the peat here. So you can see the moisture content in the lignite as compared to the peat is going to be very much higher here. Along with that, we may have a percentage of carbon as 60% here. Okay, and its calorific value is very high. It is ranging from 2500 to 25,000 to 26,000 here. Okay, so you are going to see the lignite is going to produce a large amount of heat as compared to the peat here. Okay, now next, in that case, the next type of solid fuels is the bituminous coal here. Bituminous coal is a very important coal for you, because if you just see, it is having a further classification like a caking coal as well as the non-caking coal here. First of all, just see what is the meaning of bituminous coal. Then we are going to see that what is the meaning of caking coal here. So What is the meaning of bituminous coil? Bituminous coil is a third stage of the formation of the coal here. First we are having a peat stage, then we are having a lignite stage, and then we are having a bituminous coil here. Okay, but in this case, in the bituminous coil, we are having a very less amount of moisture content as compared to the peat and as compared to the lignite here. So you can see it is having a moisture content only about 4 to 6%. Along with that, we can see the carbon percentage is very high. It is around 75 to 90%. Okay, so the carbon content in the bituminous coil, it creates a very important impact here. Why? Because larger the amount of carbon, you are going to see that we may have a high quality of caking. The caking quality is also going to be very high in that case. We can say in the simple way. Okay, and if we talk about its calorific value, it is around 33,500, which is having a way higher value as compared to the peat and the lignite here. Okay, now just see, when we talk about its further classification here, they are subdivided into two types here. The first one is a caking bituminous and the second one is a non-caking bituminous here. Now what is the meaning of caking and the non-caking here? See, whenever you are burning the coal here, okay, whenever you are burning the bituminous coal at a temperature of around 1100 degrees Celsius, so what is the are they going to produce a strong, I can say, solid residue here after the burning? Okay, after the complete combustion, or are they going to form a soft residue after the complete combustion? Okay, it simply tells you about the caking and non-caking behavior. So let us say if the fuel is burning at a temperature of around 1100 degrees Celsius and it is forming a strong residue here, then we say it is considered as a caking coal here. It is having a caking quality here. But if you are getting the soft residue, if you are getting the powdery residue after the burning at a temperature of about 1100 degrees Celsius, we say that it is having a non-caking quality here. Okay, so if we talk about the caking bituminous coil here, in that case the specific gravity is around 1.26 to 1.36. So it is a heavier type of coal here, which is having a very high value of the calorific value. So you can see the caking bituminous coil is having a good quality coal as compared to the non-caking, because it is having a high heat content as compared to the former one here. Okay, now in the case of non-caking bituminous coil, you see, first of all, it is not so much heavy as compared to the caking one, but this finds its application in the steam power plant. That is why it is also known as the steam coal here. Okay, remember this condition. Now if we talk about its specific gravity is around 33,000 kilojoule per kg here. Okay, so if we talk about the applications of this caking bituminous coal, it is generally used in the furnaces here. Okay, or if we talk about the non-caking bituminous coal, it finds its application in the thermal power plants here. Okay, just remember all of these points here. Now coming back to the next part, so how do we classify the different types of the bituminous coal on the basis of its caking quality? So first of all, the caking quality basically depends upon the amount of carbon which is present inside the bituminous here. Higher the amount of carbon here, you are going to see it is having a very strong caking quality here. For example, if you just see here, if you are having a carbon content varying from 78 to 81% here, in that case I can say the coal is going to be considered as a non-caking coal here. Okay, now but if you are having if you increase the carbon content by a little bit more amount here, for example from 81 to 82.5% carbon, or 82.5 to 84% carbon, and 84 to 89% carbon here, you can say the caking quality is continuously increasing here, and with the highest amount of the carbon you are going to get a strongly caking quality in this particular type of fuel here. Okay, so all of these points are very important for you. You have to understand that how we define the how do we classify the bituminous coal on the basis of its caking quality, which is further depending upon the amount of carbon there. So here you can see, I have already mentioned here what is the meaning of caking coil here. Caking coil is basically a coil which forms a very strong solid residue on heating to a temperature of around 1100 degrees Celsius here, okay, in the absence of oxygen, or I can say if a very small quantity of oxygen is being present. But if we talk about the non-caking coil, in the case of non-caking coil, you are going to get a powder residue here. Okay, you are going to get a powder residue here on heating the same temperature range in the absence of oxygen here. Okay, just remember that. Now So here we have seen the first, the peat, the first stage here, lignite we have talked about, the second stage, and the third we have seen the bituminous coal here. Now the next type of solid fuel which we have is known as this anthracite coal here. Anthracite coal. Okay. So anthracite coal is not mentioned here. Here we have already mentioned the liquid fuels. So here you can see the anthracite coal is representing the last stage of the formation of the coal here. In the case of anthracite coal, we have a very less amount of the moisture content. Along with that, if you just see the carbon content is very high. It is considered as a higher quality of coal here, which find its application in a various industrial processes here. Okay, now coming back to this liquid fuels here. Now what is the meaning of liquid fuels? First of all, just see. Liquid fuels are generally considered as a natural fuels here. Okay, now here we have a liquefied petroleum gas. Here may we have a petrol, kerosene, gasoline here, diesel we have. Here we are having, okay, piped natural gas we are having here. Okay, so all of those are considered as the liquid fuels here. Now in this case you are going to see the liquid fuels are consisting of the hydrocarbons again. Okay, and how we are obtaining the liquid fuels, how we are getting the commercial liquid fuels here, they are basically extracted from the crude oil. So here in this case what do? We perform the, I can say, fractional distillation process. Here we perform the cracking process here. Okay, by performing the fractional distillation process and by performing the cracking process, we obtain the different types of the, I can say, liquid fuels here. So here you are going to observe first. Here you are going to see that, let us say if you are doing the fractional distillation. What is the meaning of fractional distillation process? Fractional distillation simply means that you are heating the, if you are heating or boiling the fuel in a certain temperature range here. Okay, and each and every different type of fuels are having the different boiling points, so they are going to get separated here. How? First of all, if you just see, if you talk about the petrol here, if you want to extract the petrol from the crude oil, what do? We perform the fractional distillation process from the temperature ranges from 65 to 225 degrees Celsius here. In this particular temperature range, the petrol evaporated, okay, from the crude oil, and the remaining, the evaporated petrol or evaporated fuel is being trapped inside the another container where it is get condensed. So after condensation, you are getting the petrol as a fuel which is going to be used for the, which is going to be utilized for the further use here. And similarly, if I increase the temperature range, let us say if I am increasing the temperature range from 225 to 400 degrees Celsius, we are going to get another type of the fuel from the crude oil here. Okay, now that you have to remember. So now just see, if we talk about the important liquid fuels which you have to prepare here. So first one is having a petrol or a gasoline. So petrol is generally considered as the lightest, and as I can say, it is considered as the most volatile liquid fuels here. Okay, and how we have obtained this? By doing the fractional distillation from 65 to 220 degrees Celsius. But if we talk about the kerosene or a paraffin oils here, they are a little bit heavier and the less volatile as compared to the petrol here. And if you want to obtain this from the crude oil, what you have to do? You have to perform the fractional distillation from 220 degrees Celsius to a temperature of around 345 degrees Celsius there. Okay, now, so this is a different, so here we have a different temperature range for obtaining the different types of I can say fuels here. Okay, and in the last we are having the heavy fuels oil. So in the case of heavy fuels oil, what do we have? They are generally obtained after the distillation of the petrol and kerosene. So you are going to see that it is going to be distilled at a very high temperature range of around 350 degrees Celsius to 480, or I can say 500 degrees Celsius here. Okay, so remember the type of this solid fuel, just remember the name of the solid fuels here, their calorific value, how we are obtaining those fuels. In the case of liquid fuel also, just remember the names of the types here along with their distillation temperatures here. What is the meaning of fractional distillation, what is the meaning of cracking here, okay, and what is the temperature ranges. All of these points are very important here, okay, because you are going to expect the theoretical questions, majority of theoretical questions from this particular chapter here. And the topic which is the next topic is the calorific value. There we are having some mathematical formulations. Okay, there we have having a proper mathematical formula to calculate the calorific values here. So there you can expect the mathematical questions, or I can say numerical questions you can expect here. Okay, now let us see some comparison between the liquid and the solid fuels. What are the merits and the demerits here? So if we just see, if we talk about the merits here, okay, if we just see the merits of the liquid fuel, so generally if you just see, the liquid fuels are having a very wide applications as compared to the solid fuels here. Okay, in the power plant also, in the IC engine also, in our household also, we are preferring the liquid fuels as compared to the gaseous fuel, as compared to the solid fuel here. So I can say the liquid fuels are having a generally higher calorific value. Okay, so they require a lower storage spaces to store them as compared to the solid fuel here. Okay, now that is the second benefit. If it take if I just talk about the next part, so in this case the consumption can be better controlled here in the case of liquid as compared to the solid one. And if we just see, there is no ashes in this particular liquid fuels here, whereas in the case of solid fuel we get ashes as a byproduct. Okay, and correspondingly, due to the better consumption control, we may have a higher efficiency in the usage of the liquid fuel as compared to the, I can say, the solid fuels here. Coming back to the demerits here, the first demerit is that the cost of the liquid fuels are generally very higher as compared to the solid fuels here. If we talk about the wood is freely available to all of us here. Okay, but if you just see about the liquid fuels like petrol and diesel, they are highly very costly fuel is there. Okay, now along with that, the fire risk is very high in the case of liquid fuels because they are highly volatile, they are highly inflammable fuels here. So I can say the safety is very much required in the case of handling the liquid fuels. So I can say in the case of liquid fuels, we are having a need of very costly storage containers here. Okay, if you don't store them properly, in that case you may expect that, I can say, the major accident can take place here. Okay, the safety is a major concern in handling the liquid fuels as compared to the solid fuels here. Okay, now. So these are some of the important things related to the first part of the fuels here. Okay, so here you can see, here we have just talked about the basic things, that how do we classify the fuels here, solid, liquid and gases, and here we have talked about some solid fuels, along with that some gaseous fuel here. Okay, now some liquid fuel, not a gaseous fuel here. Now the next part which we have to cover in this particular topic, it is the gaseous fuel. Okay, because the gaseous fuels are very important for you. So there you have to cover up the different type of gases, like natural gases you have to prepare, bond gases you have to prepare, producer gas you have to see, town gas you have to see. All of those are the important topics which we have to cover here. Next, as I have told you that we have to also calculate the values of the calorific value. Okay, and we have a different representations of calorific values here. So you have to understand the concept of you have to perform the theoretical calculations for the calorific values, as well as you have to see how we just calculate those values here experimentally. Okay, so you have to properly see the working of the, I can say, boy gas calorimeter here. You have to see the proper working of the, I can say this one, a bomb calorimeter here. Okay, now let me tell you some few important points here along with that. Just see, if you want to find out the solid, I can say, calorific value of the solid and liquid fuels which we have discussed in today's lecture here, you can use the bomb calorimeter. Okay, so calorimeter are generally a device which are generally used to calculate the calorific value. So here we have a bomb calorimeter, in which what do? What we are doing here, actually, we are burning a sample of the fuel here. So whenever you are burning the sample of a fuel, the corresponding heat is going to be released, and that heat is generally transferred to the liquid which is being present around the bomb, or I can say which is being present around the closed container. So I can say the basic working principle of this particular device which we are going to see in the class here is that the amount of the heat which has been released by burning of the fuel, it is going to be equivalent to the heat which has been absorbed by the water. So just by doing the energy balance, that heat gained by the water is equal to heat released by the fuel, is a basic working principle of this bomb calorimeter here. Okay, now. So there you are going to see that we are performing the experiment on this particular device here at a constant volume. Okay, and for which type of fuel they are applicable? So generally for the solid fuels and the liquid fuels, we generally prefer this particular equipment here. But if we talk about, let us say, Boy gas calorimeter, that is the second device to calculate the calorific value. Boy gas calorimeter. You are going to observe, first of all, the Boy gas calorimeter is specifically used for the calculation for the calorific value for the gaseous fuel. Along with that, if you have a very high volatile liquid fuels here. Okay, so always remember that first thing. So as in the case of bomb calorimeter, what we are doing, we are using a basic working principle that heat released by the fuel is equal to the heat gained by the water. The same working principle is going to be there in the Boy gas calorimeter also. Okay, there again we are having a I can say burner in which we are allowing the gaseous fuel to pass, and it is burning for a definite period of time. Along with that, in this case what we are doing, we are continuously allowing the water to flow inside this particular device, and it is entering into the device and it is taking away the heat and flowing out of the device here. So I can say in the case of bomb calorimeter, we are observing the constant volume heat transfer here. In the case of Boy gas calorimeter, the heat transfer phenomenon is little bit different here. So there we have a heat transfer taking place at a constant pressure because the water is continuously in the flowing state here. Okay, now so that is the basic difference between the bomb and the Boy gas calorimeter. So there is one more calorimeter which is known as the Junker calorimeter here also. So you are going to observe the Junker calorimeter and the Boy gas calorimeter are exactly the same thing. The only difference is that Junker calorimeter is basically a modification of a Boy gas calorimeter. Okay, and it is also used for the calculation for the calorific value for the gaseous fuel here. Okay, now. So these are some of the things which we have to discuss in this particular topic here. Okay, so as I have already told you, the classes of this particular module has already been started here. Okay, now the chemistry part, the physics part is already going on from the last week, so you can join us as soon as possible here and further and start taking the classes here. Okay, now. So thank you very much. So that is the thing which I want to discuss with you. Now we will meet in the next video.